Hey there! Today I'd like to use this simple example to explain why exactly we write plus c after taking an indefinite integral, because it can seem pretty random and arbitrary at first. So the first thing we'll want to notice in looking at this problem is that since our integral symbol has no bounds written at its top and bottom, we're computing an indefinite integral. When we say that it's an indefinite integral, all we really mean is that we're trying to find some function whose derivative is 3x squared. You'll notice that the answers to definite integrals are always just numbers, but the answers to these indefinite integrals are always functions. Now, in order to start solving this, I'm going to use the power rule for integrals that we discussed last time, since that should give me some function whose derivative is 3x squared. I'll start by adding 1 to the exponent, and then dividing the whole thing by my new exponent of 3, which gives me an answer of x cubed. And we'll notice that the derivative of x cubed is in fact 3x squared. However, the problem arises when we realize that there are also other functions that will give us the exact same derivative of 3x squared. One such function is x cubed plus 1, since the derivative of a constant is 0, so these two expressions have the same derivative. For that matter, x cubed plus 2 will have the same derivative, as does x cubed plus 3, as does x cubed plus 17, as does any function of the form x cubed plus some constant. As a result, the way that we like to conveniently describe this infinite family of functions that looks like this is with the expression x cubed plus c, so that c just represents any arbitrary constant you could possibly choose to tack on there. So essentially, in general, when taking indefinite integrals, we always add this plus c after the main part of the expression to show that the main function, plus any constant whatsoever, will still result in the same derivative.